All right, here we go. This is calculus. We are starting today. I cannot contain my excitement. We are going to talk about the derivative, one of the two big things that we talk about in calculus, one of the two big concepts. So here we go. All right. Before now, you have been asked to find the slope between 2 points. You know how to do that. The slope would be y2 minus y1 over x2 minus x1. Or if you wanted to consider y to be f of x, you would write y2 as f of x2. y1 would be f of x1. That shouldn't be surprising notation. It might be the first time you've seen it, but it shouldn't be that confusing. Just another way of writing the line that's above. All right, so I'm going to focus my attention, though, mainly on this second one. All right, so let's say I wanted to find the slope of the tangent of this curve. This is the curve y equals 1 over x. There it is. All right, and I want to know the slope of the tangent at x equals 2. Let's talk about what a tangent is. There's x equals 2, and you can kind of see where the curve is at x equals 2. So what I'm trying to do is I'm trying to draw a straight line that touches the curve only once, and it represents how steep the curve is at that point. All right. So here's what we would do. I really don't know how to find the steepness of that line right now, other than just guessing. So what I could do is I could approximate it. I want the slope at x equals 2, so what I could do is I could see what the slope is from x equals 2 to x equals 3, and that might look something like this, where it passes through the point at x and the point at 2, so that might be close. If I do that, then I get a slope of negative 0.167. I could get even better by, instead of going from 2 to 3 on the x-axis, I could make my space between the x's even smaller and go from 2 to 2.1. And if I do that, just saving you some calculations, I would get negative 0.238. So I know that the actual slope is around negative 0.167. A better estimate is negative 0.238. Let's keep going with this. If I were to do it from x equals 2 to x equals 2.01, and that's making the width between the two x's even smaller, that's what I would get. I would get negative 0.249. And just one more. I'm going to go from 2 to 2.001, and when I do that, I get a slope of negative 0.25. So you can kind of see as the space between the x's gets smaller and smaller, it looks like I'm getting a slope that's getting closer and closer to negative 1 over 4. So negative 1 over 4 would be a pretty good guess as to what the slope of the tangent line is at x equals 2. All right, so let's talk about what we're actually doing here. We're talking about measuring the slope from x equals 2 to x equals something that's a little bit bigger than 2. I'm letting the space between 2 and the next x that I'm using, I'm going to let h represent that. So that the first x is 2, and then the second x is a little bit past that. So this is what I have. My y2 is the function value at 2 plus h, and my y value, my other y value, is whatever the function value is at x equals 2. And then I just subtract those x's on the bottom. There's y2, there's y1, there's x2, and there's x1. All right, so everything's there just like it was for slope. And you calculated it out. This is f of 2 plus h. This is f of 2. Remember, my function is 1 over x. This is my 2 plus h, and this is 2. So y2 minus y1 over x2 minus x1. All right, and all I did in this step was I noticed that it was 2 plus h minus 2 on the bottom, so the 2's subtract out, leaving me with just h on the bottom. And if I want to simplify that even more, look at the top here. I would like to make that one nice big fraction. When you do that, the common denominator is 2 plus h times 2. this numerator becomes a 2, and this numerator becomes a 2 plus h. I'm not doing anything other than maybe some sophisticated algebra that you already know. So if you need to pause and see where I'm getting this, please do so. If you need to email me questions at this point, please do so. I'm happy to answer them. All right, so then getting from this step to this step, I'm doing a couple of things. Instead of dividing by h, I'm multiplying by 1 over h. And then if I do 2 minus 2 plus h in parentheses, that simplifies to be negative h. All right? And then simplifying even more, I notice that there is just an h on the top, well, a negative h, and a positive h on the bottom, so I can cancel those out. So what I'm left with is negative 1 on the top and 2 plus h times 2 on the bottom. Okay, I'm just algebraically making this look nicer based on what I started with. All right? So that is the slope in terms of h, where h is the distance between the two x's. All right, but what I want to do is I want to make that h get smaller and smaller. I want those two x's to be closer and closer together until eventually the space between those two x's is 0, and I can find the slope of a tangent at 1 point instead of the slope between 2 points. Well, that's called a limit. So we're going to take the limit as h, the space between the x's, as that h approaches 0. That's what I ended up with on the last slide. And now I'm in a position to plug 0 in for h without getting 0 over 0. And if I do that, I get negative 1 over 4. Okay? Which is what I thought I was going to get when I kept looking at the examples and getting closer and closer. Remember, we kept getting things that were closer and closer to negative 0.250. Well, that's what that is. So it was a good guess to say that the slope of the tangent line at x equals 2 would be negative 1 over 4. All right? All right, and this can work for any function f of x. So let's just talk about two x values, x, and then something that's a little bit bigger than x by this factor of h, which is just a little number. We're going to see what happens when it gets smaller and smaller. So the y values of these 2 points, the y value associated with x is f of x, and the y value associated with x plus h is f of x plus h. So when I'm finding the slope between these 2 points, there again is y2, that's y1, there's x2, and there's x1. And the only thing that can really simplify is the denominator. If I have x plus h minus x, the x's subtract out, and I'm left with h on the bottom. All right? And remember, I want to see what happens as h gets smaller and smaller and smaller until it approaches 0. And that is a limit. So we are taking the limit as h approaches 0 of this function here. Okay, this is something you will need to write down on a note card. We are going to use this over and over again. This is called the gradient function of f of x. This is what's going to tell us the slope of any tangent line that touches the curve, the f of x curve, for any given value of x that you want. All right? So note that. That is very important. All right, so here's a couple of examples. The first one I'm going to do is find the gradient function of f of x equals x squared. And I'm just going to use that same thing I did before. First of all, I'm going to figure out what f of x plus h is so I can plug it in, and what f of x is. Okay, that's usually the first part so that I'm not trying to substitute everything into that big function all at once. I figure out what f of x plus h is going to look like, and then I figure out what f of x is going to look like. So that when I have this should look familiar. This is the thing that I told you was important. That's the gradient function. So now x plus h squared can go right here because that's what f of x plus h is. And x squared can go right here because that's what f of x is. Okay, so now it looks like this. H doesn't change, it's still h. So that's what I have. And if I were to plug in h equals 0 right now, I would get 0 over 0, which is indeterminate. So I need to do something else. So I actually expand the x plus h squared, and if I do that, I get x squared plus 2xh plus h squared minus x squared. That minus x squared just gets copied from above. And now if I look at this, I see that I can cross out the x squareds. X squared minus x squared is nothing. So I'm left with 2xh plus h squared all over h. And every term in this fraction has at least an h in it, so I can divide every term on top and bottom by h. So it will go away here, it will go away here, but I will still have an h to the 1 left over here. So after I divide out the h's, I have 2x plus h. Now, for the first time, I'm in a situation where I can plug 0 in for h. Before that, I couldn't without getting 0 over 0. But now, for the first time, I can. So once I'm able to replace h with 0, I do that. And what do I get? 2x. What that means is if I'm looking at the graph of x squared, and I want to know how steep that graph is for any value of x, all I have to do is double the x coordinate. So that means that at x equals 10, for example, the gradient would have a slope of 20. At negative 6, the gradient would have a slope of negative 12. Okay? You just take 2 times whatever x coordinate you want to look at. All right? So it's kind of handy. Now let's do 1 over x, which is the function that we did before, but we were looking at specific values of x. All right? So again, I figure out f of x plus h first. That's 1 over x plus h. And f of x is just 1 over x. So I plug those in. Okay? 1 over x plus h goes here, and 1 over x goes here. H stays as h. And I'm going to have to know how to work with fractions. Instead of dividing by h, I made it 1 over h again, because I don't like fractions within fractions. And then this comes from finding a lowest common denominator and changing your numerators accordingly. So I've got 1 over h times x minus x plus h in parentheses all over x plus h times x. Simplify the numerator by saying that x minus x is 0, so I've still got the negative h on top. Denominator is the same. And now since I have an h on the bottom and an h on the top, those cancel, leaving me with negative 1 on the top and x plus h times x on the bottom. And again, for the first time, I now can plug in 0 for h and not get 0 over 0. So I have negative 1 over x times x, which is negative 1 over x squared. So again, this is a general rule that will help you find the slope of the tangent line anywhere on the curve y equals 1 over x. So if I wanted to know what it is at x equals 5, the slope of the tangent line will be negative 1 over 25. At x equals 3, the slope will be negative 1 over 9. All right, so those are 2 examples. If you have any questions, like I said, please let me know, and we'll do some practice on this tomorrow.